Haskell-based spreadsheets, and from Madrid, and Ignacio will present the paper.
And the Technical University of Madrid. The talk, or the tool that I'm going to talk about, you can trace back the origin back to our final and degree project on the undergraduate at the university. This was some work with Luis. And Julio, who is here, was also a participant of that. And well, I'm going to talk about spreadsheets. I will assume that all of you know what a spreadsheet is. If you prefer to look at it this way, sorry. This is like a tabular representation of some computations that was used more than 3,000 years ago. And as every spreadsheet, it contains errors. The computational model of spreadsheets is very widespread. Microsoft Excel alone has close to 1 billion users, and with recent cloud-based spreadsheet software, there is estimated that more than 2 billion users use them every month. It is, as well as successful, it is very error-prone. And there are many horror stories that I recommend you to look for. There is, in fact, an European interest group on the risk of spreadsheets, and they have on their web page a collection of these horror stories. But the important thing is that spreadsheets are used by big companies to make decisions, and 94% of the spreadsheets contain errors. And in those spreadsheets, there's close to 5% of cells that are errors. To visualize this, you can here have a spreadsheet, and every cell that is colored in red is expected to have like an error. To visualize how many errors there are usually in a spreadsheet. So what are the solutions that they are proposing to work with this? Well, they recommend you to follow some development patterns and design patterns, and also to use some analysis tools. And lately, they try to predict what the user is trying to do in order to prevent the error. So we thought about this, and we started to think, why not using functional programming? At the end, spreadsheet software, in some sense, are a declarative, side effect-free computational model. And even maps and folds occur naturally. You start working with ranges to apply a transformation, you filter, you reduce the cells into one value. But the problem is that spreadsheet lacks some of the functionalities of modern programming languages, especially type systems. And many of the errors that occur in spreadsheets are related to this kind of programming errors, the lack of a decent type system. There are dynamic values, casting of them, how to interpret blank or empty cells. You start to work with ranges that are not very delimited, and you apply functions to ranges that are not complete. And we know that type systems can help you to prevent some errors. We have seen how TypeScript, for example, has taken the JavaScript world into introducing a type system on the language. So we started with an hypothesis that maybe if we reconstruct the spreadsheet idea around a modern functional programming language that has a type system could improve, like how do we work with them. And if we start thinking about the spreadsheet as a real programming environment, we can start thinking also about how to introduce some of the techniques that we use, how to apply testing or advanced testing techniques like property-based testing, how do we debug our spreadsheet. And this is when we came up with Haskell. This is the tool that we propose, in which we want to introduce all of these features that modern programming languages have. But Haskell is not a substitution of the things that we have. It's not either an implementation of Haskell or how to interact with Haskell through an spreadsheet. The idea of the tool is more of like exploring what these languages can provide, or in particular Haskell can provide to this ecosystem. And in Haskell is used as the base language of the cells. Well, we have some syntax sugaring for facilitating the interaction with the ranges at the cells. But the whole spreadsheet is a Haskell program, and users interacted in a what you see is what you get way. The tool is available in this GitLab. And these are the main design principles. We don't want any backwards compatibility. This is just an exploration tool. We don't want to import existing spreadsheets. We just want to explore. But keeping all of this design that is so successful with these tools, and in which you have a what you see, what you get interface, you type in the cells, you see the results, but we wanted also to provide a separate code editor to write some functions that we later are going to use in the spreadsheet. And in the cells, we will be working with basic types, but also we explore the idea of introducing some aggregate values, some complex data types, to facilitate the interaction and the computations. There is a separation between the representation, the appearance, and the internal representation, such that you can implement your own show function, or to differentiate between how do you write the data and how do you see it on the cells. And at the end, everything that you write is translated into a Haskell program, in which you can have all of the benefits of the languages and all of the optimizations of it. This is an example expressed to have an idea about that. This just represents the grades of an student on different subjects in a computer science curricula in Technical University of Madrid. And in the first four columns, you have the year, the name of the subject, the amount of credits, the grade, and the final qualification that is derived from the previous one. We have a validator function that checks that previous values are correct. And in the last two columns, we have some calculations regarding the grades and the amount of successful credits. So let's take a look at how did we write this spreadsheet with the Haskell language. In the cells, you can write any Haskell function. You can call any already defined function, for example, sum, and apply it to a range of values. Or you can start to compose with the thick width, fold, reduce, and everything else. You can reference other cells, and the notation for the ranges, which is similar to a list, then is the sugar into the corresponding range. On the external module, on the companion code editor, you can define your own data types, just as in Haskell, and use it to define functions that later you are going to evaluate in the spreadsheet. In this case, we are working with more complex types. For example, how to handle errors in the calculations of grades using the either pattern. But we can also introduce new types. New types. Because it's an already known and very used pattern to prevent errors when you are working with the same types, for example, with numbers, and you don't want to switch the order of the arguments. It's a very common error, especially if you are referencing cells, which are not specifically typed, or you cannot differentiate the name just by the reference. So new types are supported, as in Haskell. And then you can define your own aggregate data types. And in particular, we have a notation to call, for example, ranges of cells that later will be used as arguments. So as the same way that we convert ranges to lists, we can also apply them to the data constructor. There's more features, for example, as I said before, how to apply data validator, that you can define a validator that is triggered after each cell evaluation to know that everything is properly written. But there is one more important thing that we have done, and that is the treatment of blank cells, because usually they are an essential feature of spreadsheets, and we have to deal with them here. Blank cells are a fundamental feature of spreadsheets, but it is also one of the source of other errors, because at first you can perform calculations without incomplete data. You have a table with empty cells. You can reference it, apply sums. But when you have to handle more other complex cases, you need to start to detect when are you working with a blank cell, an empty cell, when it is an empty string, which is different. And also, it is not clear how systems or spreadsheet systems deal with empty cells. For basic additive usage, you can always replace it by a 0, but this does not apply to other arithmetic operations. You have the division by 0 error, or even in non-arithmetic contexts, you need to, as I said, to deal with questioning if is it a blank cell, is it an empty string, and also you can receive an empty cell as an argument, but you cannot return that in the spreadsheet. You need to convert it to an empty string. Also, different spreadsheet systems deal with empty cells differently, so you cannot port it to other programs. This is a problem with current spreadsheets. And the thing that we did was to propose a system of default values that we will apply when we reference empty cells. For a single cell reference, we can replace it by a default value. So, for example, if we call A4, we say, OK, if it is blank, replace it with a 1. But default values must not conflict, because if you understand that A4 is a number, later it cannot be a string, because then there is idea that one thing is representing multiple things at the same time. The default notation also applies for ranges or for lists. This is equivalent to define on the left. The list of A4 to F4 is default 1. It's like substituting every cell with a 1 in case of it is empty. But we can also extend it to function arguments. So when we define the function, we can say, when you are applying a plus, you sum two elements, for example, treat the default value as 0, or maybe the empty string, or a Boolean. But it is also applicable for complex data types in this definition. And when we define, for example, our custom data type, you can say the grade, if it is empty, for example, it can be the absent grade. And we formalize all of these substitution and this default extension. Talking about the tool, Haskell is, well, three different things. The most important one is, well, the definition of the language is the heart of the system. It implements the default system resolution and implemented with template Haskell. Then we have the runtime, which provides all of the functionality related to the evaluation of spreadsheets. It receives the cells and the external module, and implements the desugaring, all of the dependency analysis to detect cycles in the reference of cells. It's in charge of compiling and evaluating the module or the program, and also dealing with the error handling of anything wrong that can go in the execution. And finally, there is the Haskell application, which is responsible for the interactive behavior of the tool. It has a client side, which is web-based, and the server side, which is an application implemented in Elixir with Phoenix, and client and server communicate using a JSON-based protocol through WebSockets. As a quick conclusion, this tool is a proof of concept. The prototype is kind of satisfactory. We can interact with cells. We can test all of these ideas. We can explore. It gives us a platform to test our ideas and how we can extend the spreadsheet usage with it. But there is plenty of room for improvement. For example, efficiency. It could be faster, or we can improve all of the usability things. Also, how do we deal with more staggering of the code? And for future work, we also consider the use of some more complex type system, not to be specifically tied to Haskell, but maybe implement or use dimension types, or introduce liquid types in the definition of cells or what they can hold. We also want to explore other kind of interactions that are common in spreadsheets. For example, autocompletion of code, how complex values or list of values, when evaluated, spill and produce a list of cells, and many other ways for interacting with the spreadsheet. Also, we don't want to be limited to just use this language implementation, but we also want to explore how other tools or languages, for example, Elixir or different paradigms, how to introduce constraint logic programming in the spreadsheet can help the development or the definition of them. This is something that have been done before, but we also have this interest and want to explore how this environment can be benefited for the use of modern programming languages. And I have a quick demo to see the tool, and also you can ask questions during the demo to see and explore the system. And thank you very much. So this is a tool. It looks like modern spreadsheets. You can evaluate code slowly, because one of the things, I forgot to turn up not the power server, but the performance mode. So one of the things that why is it kind of slow is that for every cell update or input value that we do, we are generating a Haskell program, compile it, then run it, parse back the results and possible errors, and then we have the result. This is just the most basic implementation that we can do. But starting from that, we can start, for example, to use the REPL for interactive usage that could be faster, but not different, or should not be different than compiling your program and execute it. We can reference cells, for example, itself. And if it detects an error, for example, a cell reference, we know that because of the dependency analysis. We can also reference, for example, the cell next to it. And if we do that, the error that we get is that we are referencing a black cell without a default value. So we can say, OK. We can say that the default value is a string PADL. And if it does not find the cell defined, you can reference it here. We can also have some Haskell definitions. For example, say that x is an integer. And then we have it here, the x. Please don't. OK. Oh. Sorry. Well, this is great. Now it is a 3. And PADL should have been updated. It is not, probably because it broke. But I mean, this is the demo effect. But if you have any question regarding this system, or want to have an idea, or you want to ask anything, please feel free to ask.
We have plenty of time for questions, so please.
During your demo, which one of the errors were errors that your program detected, and which one of them came from the compiler?
This compile error, the loop error, it was parsed from DHC. All of the dependencies error are done before compiling to the program. So in case that we detect, for example, a cycle, it is done before executing it. And also, every time that it detects an error, the dependency analysis detects which cells are separated from proper evaluation from error evaluation, the error side, in order to keep, for example, the first value evaluated and not breaking the whole spreadsheet.
So why is B not updating?
Let me see the logs.
Okay. Would that be a type error anyway? Because You have a string default value and you have an integer in C.
So it's not returning the result. I'm not sure why. Then if you change the value of cells until they are not evaluated, they can change the.
Yeah, but is this a type error?
I don't know. It's a very interesting question. We didn't know about that. With that. But yeah, that default substitution with different types might be a source of type errors, and that's a good thing to look for.
The only thing we guarantee for default substitution is that it terminates. As there's no circularity between what you write in the right panel and what you write in the cells. So in the end, you obtain infinite time. You obtain a Haskell program, and whether it compiles or not is another question. It might be rejected by Haskell.
Yeah, I wonder why did you choose this Haskell programming language for this project? It seems to me that for spreadsheets, perhaps an eager functional language would be more appropriate. So what were the reasons behind this?
As I said, this can trace back to our final degree project, and at that time we happened to like Haskell, so we started working with it. But what we noticed that lazy evaluation might only apply or benefit here in very specific computations, is if you define infinite lists or work with infinite lists here in the spreadsheet, and probably an eager evaluation system.
Yeah, besides that, for instance, I don't know, you use Haskell template. That useful?
Very easy way to implement this kind of extension in the language, because
it's a very mature language, so.
Works. So D1 is not defined. Oh, and here is like a type error, parsed from the compiler. I think that by default it is treating this value, for example, as an integer. So if I change that and reevaluate, either. So there is something error in it. Yeah, the template we were experiencing also in this template Haskell or this transformation of programs. So we didn't switch to a different language when we implemented this. Although we all of these application, if we go back to here, the application and the runtime is independent of the language definition, kind of, instead of the sugaring. And in this way, we have all of the framework to develop different implementations and use different languages to work with the spreadsheet.
Why the server is implemented in Elixir? You currency for?
No, it's actually because the Phoenix.
Okay, okay.
Very well communication through channels, and well, we used to develop these kind of applications.
So I was looking at that type error you were getting on that last example there. Benefits, I think, of things like Excel is that it's very accessible for the average user to come and just bang out a spreadsheet to do some calculations for them. But I think if my mom were to come and see that type error, she'd just freeze up, and that'd be the end of it. So,
and the first thing that we took into account when we wanted to develop this spreadsheet system is that we wanted to use a more complex environment because we know how to program, and sometimes we find ourselves limited by what you can do with spreadsheet formulas and Visual Basic or Basic. So we don't want to be a We don't want to be a tool that substitutes Excel. We just want proof of concept that help us to find some things that we don't think about usually. So for example, we first had the implementation of the spreadsheet system, this idea that what if we evaluated Haskell code inside a cell? And later we started to think, oh, but we can have a separate module to define all of our helping functions because usually the formulas are very complex. And later we thought, what do we do with empty cells? How do actual systems interact with it? What is the definition? What is the semantic of an empty cell, and how do you use it in the whole spreadsheet? And this is not defined. If you want to know, for example, what LibreOffice does with empty cells, you need to go to the code implementation and look for, if it is double, then do this. It is not defined anywhere. So it's a great environment to think about these kind of things and other kind of interactions. For example, working with multidimensional arrays, how do you reference and understand the enumeration of ranges? If they are, for example, sum this rectangle, how do you apply the evaluation? It's just a way of putting something in a strange place and see how it happens to be.
I have also one final question. In your formulas, you always have shown that you have given the concrete names of the cell, like D1, D2. Can you also parameterize the formula over the rows? Because sometimes you want to have a formula in one row which you want to copy it into another row, and then so you want to parameterize your formulas over the rows, also over the columns.
We don't have a proper syntax for referencing rows or columns. Mm-hmm. We can apply ranges for that. So, for example, if we sum A1 to A10, okay, we references a range without default values. To be working unless I didn't pull the latest changes. But we support a way to reference ranges. It is not, maybe if I understand it correctly, you are also talking about parameterizing functions, maybe regarding receive a list.
Or cells, because sometimes in spreadsheet programs you have the possibility you copy one row into another row, and then all the cells which are updated related to the other row. And so you have more, and if you want to have this flexibility, I need some parameterization over the rows.
Rows around, because then you will need to update all of the cells. But later, all of the columns or maybe rows could be just understood as a list of cells and work with that.
Mm-hmm. Okay, so thank you very much again for the demo and the discussion. So.